In this video, I will show you how I rooted an easy machine from Hack the Box. The attack involved exploiting an insecure direct object reference or IDOR to find a hidden admin page. That allowed me to perform command injection on a particular functionality and gain foothold to the machine. I would say this is the hardest part of this machine, as I need to execute a unique bypass technique. Inside the box, there is another hidden service that is vulnerable to PHP code injection that allows me to gain root access. This is the first time I'm solving Hack the Box machine again after 2 years, so even though this is categorized as easy, this felt difficult to me. Let's get started. I will first connect to Hack the Box via OpenVPN. I'll run my VPN connection in the background, but I will redirect the logs to a file. This helps me troubleshoot connection issues. Let's see if there are any errors. Logs are moving, so I think we are good. Next is to add the IP address of the target on our local host file. Typically, Hack the Box machines end with .htb. I also put another alias, but this is not really required. The IP address came from Hack the Box website. Let's see if we can ping this. We are getting a response, meaning we have full connectivity. Just do note that sometimes if there are too many players, you may experience a slow connection. Whenever I'm targeting a box, I always stay organized, so let's create a dedicated directory for Nocturnal. We need to perform scanning first, so let's also create a subdirectory for the output. Nmap is my main tool for scanning. -SC to execute default scripts that helps get some of the basic information. -SV for version detection. Let's scan for all ports. And let's speed up the scan by specifying the minimum rate. I always use 10,000, but it depends entirely on the network bandwidth. Then we will put the scan output under the subdirectory we prepared. Useful in case we need to get back to it later. Let's run this and wait for a bit. Sometimes the Nmap scan will take longer, especially if there are too many ports. One thing I do while waiting is to perform another scan, but this time I only care about the open ports and not the service information. This allows me to quickly move on to the target without getting stuck waiting for Nmap. As we see here, we have 2 open ports. Most likely the box is only running a web and SSH service. Going back to Nmap, we can confirm that it is indeed only have 2 open ports. Using different tools in enumeration will help you confirm things accurately. In this case, the 2 tools I used showed the same information, so I'm confident that the box is only 2 open ports. There is nothing really interesting on the SSH service as it doesn't have that many vulnerabilities. But we can see here that the operating system version is Ubuntu. Same with the web service. It also shows Ubuntu, which confirms the information we see from SSH. The type of web server is also given. It is Nginx, so we might be able to perform some path normalization or reverse proxy attacks later. If we look just below it, we see a redirection. This is important to note, especially when we are fuzzing directories and endpoints. That may not be too clear at this point, but I'll try to explain more later. Let's open Firefox to see how the website looks like. We will use the hostname we found from Nmap output. Welcome to Nocturnal. From here we can see that we can log in. It also allows user account registration. There is an upload functionality. We might be able to upload a server-side script that we can call to perform remote code execution. It allows access from anywhere. This might mean we can access our files from a different endpoint. User-friendly interface. Not sure yet how will this help us with our enumeration. Collaboration features. This may be related to the file access functionality it mentioned above. The site also have regular backups. This is interesting because we might be able to access backup files over HTTP, 24/7 support. There may be a client-side attack we can perform. An example would be sending out a phishing email to the target. We see at the bottom the email of Nocturnal support. We didn't see an SMTP port, so phishing attack might not be the way. In that case, we must focus on other vectors. Let's go to the login page. We can try out some common credentials, for example, admin. It didn't work. Let's try admin password. Same. How about Nocturnal? Or Nocturnal password. Nope. Since we don't have luck with some quick default credential enumeration, what we want to try next is SQL injection. This is a classic attack that can bypass authentication mechanism. If we are lucky, we might land into a high-privileged account or hidden endpoint. Let's try a basic one. Sometimes the comment at the end of the payload matters. So let's try to have different variations. Semicolon first. Then #sign. Nothing worked also. so this might not be vulnerable. What we want to try next is to register for a low privileged access and continue our enumeration from there. Let's create a user clown with same password as the username. Now let's try to log in. Okay, so we have a file upload functionality here, but we don't see the other features we saw from the landing page, such as backups. Those might not be intended for low privileged accounts. Let's create a simple text file and upload it. It turned out that we can only upload these file types. That means there might be either some blacklisting or whitelisting on the server-side code. Given this behavior, we can also think of other attacks, such as bypassing the security mechanism to upload a malicious PHP file. For now, let's try to create a PDF file and upload it. It accepted it, and we see our file below. If you notice, this is not a real PDF file, but it still processed it. This means the server-side code is only checking the file extension and not the content type. These small details are very crucial if we need to do file upload bypass later. If we hover our mouse pointer to the file, we see at the lower left side the URL where we will be redirected. This is interesting because we see two parameters which we can exploit. If either the username or file parameter is vulnerable, we might be able to gain immediate foothold. So let's open this on another tab. Since this is not a real PDF file, it will not be displayed properly, meaning we won't see anything. But let's try to perform enumeration on the URL parameters. Let's try first the file parameter. Putting a non-existent file returns an error, which is expected. How about if we change the username to admin? It still says file doesn't exist. Let's change the username to dummy. It says user not found. This means manipulating the username parameter allows us to find valid accounts. That also means we might be able to list files owned by other users. Let's verify that. Let's create a second user clown too. And let's log in. And manipulate the username parameter to see if we can see the file uploaded from the first clown account. And there it is. Even though if we are logged in as a different account, we were able to see the file owned by a different user. This confirms that the website has an insecure direct object reference vulnerability because we were able to access objects not intended for our existing account. To exploit this vulnerability, we want to find more users, but doing that manually will take forever, so we will use a tool to help us. We want to perform fuzzing against a word list of known usernames. I always use SecList as it contains most up-to-date word list of any kind. We can try the 10 million usernames, but based from the file size, this might take forever. And since this is an easy box, we should not need to perform fuzzing for hours. So let's try the one above it, which has a smaller file size. Now that we have the word list to use, the next thing we need to do is find a fuzzing tool. Fuff is always on my list. We pass the word list we picked above, then the URL we want to fuzz. We need to put the fuzz keyword on the parameter to enumerate. And since this is an authenticated enumeration, we need to set the proper cookie. We can easily get that in Firefox. Right-click and inspect the page. Go to Storage. And get the value of the PHP SysID. Once we got that, we can now hit Enter to start fuzzing. There are a lot of hits, but most of them are false positive. What we can do is to filter it by removing responses with a specific number of words. Now we have a cleaner output. And we see another user other than admin. This may still take time to finish, so while waiting, let's go back to Firefox and explore Amanda's account. We see here that there is an ODT file. We can open this in LibreOffice. This is just similar to Microsoft Word document. We are looking at a letter from Nocturnal IT support team showing Amanda her initial password. There is a note to change the default password on initial login, but most users often forget this. So let's try accessing Amanda's account using this default password. But before that, let's quickly see if our fuzzing was able to find additional users. It got two more, ASD and Tobias. The first one looks like a test user created by another player on the network. But Tobias looks legit. Whenever I get any type of credentials, I always put them into a text file. Passwords will be on a pass.txt. Let's put here Amanda's default password. And users is on users.txt. And this will contain some of the common usernames like root, admin, and the others we found out. After that, we can quickly do password spraying against the SSH service. If we are lucky, we might be able to find a direct SSH connection to the server. We will use Hydra to perform the attack. Let's pass the list of users. And next is the password file, which right now contains only one entry, which is Amanda's default password. The target protocol will be SSH. Let's run and wait for a bit. It shouldn't take too long since we only have very few entries. All right, it's done, but it wasn't able to find anything. This means SSH might be a rabbit hole, so the next best thing to do is to log into the website using Amanda's credentials. The default credentials worked, and we see here that there is an admin panel. Let's go and explore it. This shows the different PHP files on the server, which seems reflecting the various site functionality we saw from the landing page. At the bottom, it allows us to perform backups. I assume this will back up the files uploaded on the server. But let's see by entering some random backup password. Oh, so it also backed up the PHP files together with the file uploaded by users. Backup functionalities like this often run system commands in the backend, so this is a good place to perform command injection attacks. So let's figure out how the backups are being performed. If we click the admin PHP, it shows us the code. This most likely contains the backup code, but let's have a look. There is a function that sanitizes the file paths, good for protecting against directory traversal attacks since it only returns the base name of the file. There is another function that lists the PHP files, which is the one responsible for displaying them in our current view. Then another one that performs sanitization. This is probably used for protection against command injection attacks. Not sure at this point where is this exactly used, but let's move on. Let's skip the HTML code as we are only concerned for server-side scripts at this point. Going at the bottom, we see here that actual code that allows the user to perform backups. It looks for backup post parameter and make sure that the password parameter is not empty. The password is sanitized using the clean function we saw above. The backup variable is not user-controlled. We cannot inject anything here as this is done on the server side. This means our entry point is the password parameter. Just a few lines below, it compares the result of password sanitization. If it detected any blacklisted characters, it will return an error. Do note that this is a strict comparison, meaning both data type and value should be the same. If this is doing loose comparison, we might be able to execute some PHP-type juggling attacks. The actual shell command it is using is zip. There is a -x flag which excludes the backups directory from the resulting compressed file. -r for executing it recursively. -p for specifying the backup password. This is the location where we can inject arbitrary commands. It is followed by the backup file, which we cannot control, and some logging at the end. Now, going back to the sanitization function, we see here the different blacklisted characters. These are the typical shell characters used when running commands inside Linux. It seems hard to bypass since it looks like it already included all possible characters. Let's go ahead and start playing around with the password field. I'll type a Linux command with semicolon to confirm the blacklisting. It should return an error. Confirmed, the blacklisting works. But it is hard to perform enumeration this way since the value on the password field is hidden. We can either modify the client-side HTML code to show the value or use a proxy to manipulate the requests. Let's use a proxy. We can point Firefox to a proxy server using this plugin. Then let's open the proxy server and Firefox side by side. In this demo, I'm using mitm proxy. If you watched my older videos about man-in-the-middle attacks, you will be familiar with this tool. But for the sake of new viewers, I put the link in the description below. Now I'll type again a password on the form. And we see here that the request has been intercepted. We can use our mouse to click on the request as mitm proxy is interactive, or we can just use the keyboard. I'll just hit enter to see the details of the request. The first window shows us the request details such as headers. Then at the bottom, we see the post parameters. This are URL encoded, but mitm proxy will show us the decoded form. On the next window, we can see the response from the server. We see here that the blacklisting works because it returned an error. Let's try to inject a simple payload that will connect to our attacker-controlled HTTP server. Once we verify that it is successful, we can upgrade it to a more sophisticated command such as a reverse shell. So I will just open an HTTP server here at the bottom of the terminal so we can easily see the callback. To edit the request body, which includes the post parameters, we can press E. Then we can click the request body at the bottom, or just enter A. This is one of the few things I like with mitm proxy as it mimics some of the Vim commands. Then it will allow us to edit this in a Vim editor. As I mentioned a while ago, the post parameters are URL encoded. So whenever we put our payload, we must URL encode it first. Let's URL encode a basic curl command for demonstration purposes. I always use this site for quick encoding and decoding tasks. Once we typed our command, we can just hit encode at the bottom. When you perform pen testing and ethical hacking, you must be aware of the URL encoded form of some of the basic characters. An example is space character, which is %20. This saves you time in generating your payload and understanding the formats when inspecting exploits or just investigating attacks from log files. Going back to the post form, we can just paste the encoded command here. Then, since we're inside Vim, we can just go to command mode and hit W and Q to save. Once we are ready, we can hit R to replay the request. Since space is one of the blacklisted characters, the server didn't process our request, but it just returned an error. So let's slow down and analyze the logic of the code. The backend command is using zip. The only entry point we have is the password parameter. If there is no blacklisting, we can just submit a password like this, which will be expanded by the shell. But the problem is that backtick is one of the forbidden characters. We can also try other forms of shell expansion using $sign in parentheses. But again, $sign is blacklisted. We can use payload, all the things to look for possible bypass techniques. We might be able to find a character not included in the blacklist that will help us. The first one is using internal field separator, but it uses $sign and curly braces, so this won't work either. Same with the next one, which leverages brace expansion. There is also an input redirection bypass technique which uses less than sign and forward slashes. Although those are not blacklisted, it may be difficult to achieve a reverse shell since we need to incorporate spaces on our payload. Quoting techniques are not possible as well. It leverages ampersands, which is forbidden. The next one is interesting. It uses a tab character as alternative to spaces. This might work, so let's give this a try. We can insert the URL encoded version of the tab character as alternative to space. Then, in order to prevent further processing of the next part of the command, we can terminate it with a hash sign, which signifies comment in Linux. That is not blacklisted, so it should work fine. There is still a minor problem here. Since we cannot induce a shell expansion, the password parameter from zip command will treat our payload as a literal password. That will prevent us from executing our command successfully. So in order to work around that, we need to pass a plain text to zip command telling it that it is the password. Then add a new line to tell the shell to treat the next set of strings as a separate command. With this strategy, the zip command will only get the first set of strings as the password input. Then it will let the shell to process the next set as a separate command. Let's now go back to our proxy and try this payload. We will again edit the post parameter and it will bring up the Vim editor. Then let's paste our URL encoded payload, save and quit. Then hit R to replay the request. We got a callback. This confirms that our command injection payload is working, and we can now upgrade this into a reverse shell. If you find my content valuable, please support me by liking this video and subscribing to my channel. First is we need to open up a listener. Reverse shell payloads often contain multiple odd characters that may break when being processed. Since we have a file upload functionality on the server, the idea here is to upload a bash script that contains any kind of complicated payload. Then leverage the command injection vulnerability to execute that bash script inside the server file system. Once triggered, that script will connect back to our attacker listener. So let's prepare our bash script that we will upload. We can use revshells.com to find different payloads. Let's put our IP address here. Then change the port. We already have our listener ready on the terminal. We just need to copy this and put it on our bash script. After that, we will upload this to the server. Since the server logic only checks for file extension, we can easily bypass that by putting a .pdf at the end. Then let's go to the main upload site and select our bash script with PDF extension. Then we see here the script which we can execute under Uploads folder. Let's update our command injection payload we call the bash interpreter. Then we put the relative path to our bash script. Let's copy this. Then let's paste it on the form parameter. Save and quit. Hit R for replay request. We didn't receive a callback. Something must have gone wrong. Let's see if we can find something on the response. Looking at the error, it is complaining that it cannot see the file, although we were able to upload it successfully. This might be because of the URL encoding. A nice trick here is to wrap the command inside double quotes. Let's modify our payload. Then replay again the request. This time we got a successful callback. We don't have a stable shell yet, but we are running now as data. We can also see the files inside the htdocs path. Let's check if we can see some useful information. There is a folder which seems containing the database file. There is really a DB file here. Let's dump the content. This is an SQLite database, and we see here the users and hashes. We can transfer this to our attacker machine to inspect further. Let's use netcat to easily transfer this. We can open a listener on our local and redirect the output to a file. Then inside the victim machine, we can perform similar command, but in reverse. It's transferring now. We don't have an indicator whether the transfer is finished, but we can check the file size whether it is continuously increasing. If it no longer changes, then the transfer must be complete. After that, we can open SQLite on the CLI and dump the contents. There are 5 hashes here that we can crack. Let's put this on a text file. Then we can copy this and put it in an online cracking tool. Typical places to go to crackstation.net, as this can crack most weak hashes. Let's paste them here and crack them. It was able to recover 2 hashes. Every time we find any type of credentials, it is always best to perform another round of password spraying. This is a good enumeration practice that avoids us going into rabbit holes when there is an easy way in the server. So let's update our username file to add the new users we found from the database. Same thing with our password file. We will add the 2 passwords we recovered from Crackstation. Then let's run again our hydra command to spray the credentials. We got a hit. There is a valid account for user Tobias. We can now try to log into SSH using that password and username, and inside we can confirm that we can read the user.txt. Let's perform some basic enumeration. First, we need to check if Tobias has any sudo permissions. He doesn't have. Then we go and check the files in his home directory. We won't see anything on the history files because they are sym-linked to dev null. Let's do a recursive directory listing. Most of the files here doesn't have any content either as indicated on their file size. Let's go outside the home directory and see if there are any other users. It is only Tobias. It is also possible that there are still other users, but they just don't have a home directory or they are located somewhere else. So let's open the password file. Most of the users here are application related. This confirms that Tobias is the only possible users to enumerate. Let's quickly check the root file system to see if there are any unusual data. There is a root bash history, but we cannot read this as we don't have permission. Other than that, everything looks normal. How about in /var, which is one of the usual places to store application related data? Let's go inside www. There is the Nocturnal database folder, which we already enumerated a while ago, and the actual directory that contains the PHP files. So nothing interesting on them. But there is an ISP config symlink here. In Linux, a red symlink typically signifies that we don't have permission on the real directory it is pointed to. We can verify that by trying to access it. Yeah, we really don't have permission. But this gives us a clue that there might be another application running inside the server. Let's take note of that for now and move on. There is another directory that contains PHP scripts. Let's try to list the contents recursively. There are 2 files. Let's open the first one. If we are lucky, we might be able to see some credentials. This is launching a PHP application. But other than that, there is nothing interesting. The directory where it saves the session is the same path where the symlink is pointed. Let's open the second file. It looks similar with the first one. Let's diff their contents. There are a few differences. The second one seems a default script that doesn't have values from some of its parameters. But in any case, I still don't see anything interesting here. So far, the only thing that stands out on our enumeration is the ISP config application. Let's see if it is really running by checking on the process listing. Nothing here. Some applications may not disclose the name of the process, so next thing we can do is to check for the listening ports on the server. We have several services listening on localhost. This means we need to perform port forwarding to access them on our attacker machine. The first one is an SMTP port. Second and third are related to a MySQL database. I think I forgot what is port 587, but the one running on port 8080 seems really interesting. Probably this is the ISP config application. The service running on port 80 is the main Nocturnal app as it listens on all interfaces. The rest of the ports are just normal Linux services, so we can just skip them. In order to access port 8080, we need to perform reverse port forwarding. I always use Chisel as it's one of the easiest tools to work with. In order to run this, we need to transfer a binary on the victim machine. Then we will run a Chisel server on our attacker on port 8181. Then the victim will act as the Chisel client that will connect to our server. We paste here the IP of the attacker, then the port. We need to put uppercase R for reverse port forwarding, followed by the port we will use on the attacker to access the service. This can be any port, but I usually use port 2222. Next is we need to specify the address where the ISP config app is listening, which is localhost. Finally, we specify the port as well. Once both sides are talking, we can now go to our attacker and access the service. We can now see the ISP config app login page. Now that we have new login page, the next best thing to do is to try to reuse the credentials we got so far before doing brute force attacks. If we think of it, we have 3 possible users: admin, Tobias, and Amanda. We can eliminate Amanda as she is just a Nocturnal web user. Tobias, on the other hand, is a real user inside the server. We can try to guess that Tobias is the admin of all apps running inside. So it is possible that he reused his SSH password for the admin user of ISP config. So let's try using admin, then paste Tobias SSH password. Looks like we are in. So in situations like this, it is best to analyze first and connect different pieces together before performing more devastating and noisy attacks like brute forcing the login page. Based from the dashboard, this looks like a system manager app. It handles websites. It performs monitoring. We can also see the help page here, which can disclose the version of the app, some system settings perhaps, and a page that contains tools. When I see apps like this, one of the first things I look for is if it has a functionality to run system commands. Typically, apps like this may run under root user. So if we were able to find a functionality that allows us to run shell commands, we may have an easy path to root. For now, let's move on and do some other quick checks on this main dashboard. There are information about mailboxes which may explain the SMTP port we saw from the listening services a while ago. Then it has different site information, which may mean that the Nocturnal website is managed under ISP config. There are also some database information here that explains the MySQL-related ports we saw. Let's go to Tools page and look for a functionality that will allow us to run shell commands. There is a user setting here, but not really interesting as we are already admin. This can be of value if there are multiple user hashes that we can discover and crack. Not sure what a resync tool is, but from the looks of it, seems not interesting as well. Let's go to the system page. There is only one user, which is admin, so we have no chance of finding other user credentials. There is one service running, which is the Nocturnal web app. Let's check the main config. It looks like some of the settings here are not set properly, so there might be nothing of value here. Let's go to the language editor and open one of these. It is located under the directory where we don't have access. How about if we export it? Oh, so this is a PHP file. There is a long list of settings here. We might be able to inject code here if we can edit it. There is an import button. And we see a warning not to import language files from untrusted sources. So this might mean these files can be vulnerable to code execution. We can try to import our own language file with a shell command inside and let the server process it. So let's first open again an HTTP server to receive the callback. Then let's copy this whole language file and paste the content. On the top, let's put a system command that will reach out to our HTTP server. And let's try to upload it. It looks like it processed our request, but at the bottom, it wasn't able to run the system command. So it's either we are using the wrong format or this is not vulnerable. We can quickly look for ISP config exploit in Google. We have a first hit that is about a PHP code injection for versions lower than 3.2.11. Let's confirm the version we have. Based from the language file, it is 3.2.10. But let's confirm from the help page. Yeah, it is the correct version. So let's open the vulnerability information and check more details. The vulnerability happens when the admin allow lang edit is enabled. It looks like it is indeed enabled as we were able to upload our language file. At the bottom, we see a proof of concept. Let's open it. This is a PHP script, so let's copy it to our attacker machine. Let's paste it here and check how to use it. It accepts 3 parameters, the URL, username, and password. Let's run it. We will point this on our local host connection running in port 2222. Username is admin, and password is the one from Tobias. It didn't work. Not sure why, but from the looks of it, the CSRF token was not captured. This may be a redirection issue, so quick fix is to put a / at the end. Now it worked. Are we root? Yeah, we are. And we can read the root.txt. So using different vulnerabilities, we were able to gain foothold and perform reverse port forwarding to exploit a hidden service inside this box. I want to deep dive on the vulnerability, but I will just do that on another video. Thanks for joining me until the end. I hope you learned something today. See you on the next one.